Hi there. I'm Deborah Sharmalus with Technically, a news organization that serves the community of technologists and entrepreneurs. Today, ahead of our May 10th Developers Conference, we're talking about Crossbeam's unorthodox choice of the programming language Clojure with Nick McAvoy, who is an engineering manager at Crossbeam. We're releasing this series of technical talk videos in the lead up to Technically's Developers Conference, part of Philly Tech Week presented by Comcast. Nick, passing it over to you. We're excited to hear your expertise on the topic.
Thanks a lot, Deborah, and really appreciate Technically for this whole conference. And yeah, as Deborah mentioned, my name's Nick. I'm an engineering manager here at Crossbeam. We decided that all of our teams should be named after kinds of beam, and my team was a little outside of the box, and we decided we would be the Pinto beams. And we really ran with that, and it turns out our mascot is a can of beans. And one of the best parts of my job is I can talk with an Etsy seller for 6 months as he meticulously makes a bunch of these little plush mascots for us. So a little side note there, but yeah, so we're just one of the 3 teams we have here at Crossbeam. And yeah, what is Crossbeam? Just talk for a second about that. Yeah, so we're a startup. We've been around about 4 years, and we have kind of invented this category of a partnership ecosystem platform. And yeah, it started right here in Philly. Our CEO, Bob Moore, this is his 3rd company. And we're basically helping businesses collaborate better, having a secure platform for the exchange of sales data for collaborating and driving more revenue. And yeah, we've got just coming up this May, the Supernode conference here in Philly, really the first conference of its kind. So it's been a very kind of exciting ride here. I've been with the team since year 1. And yeah, so since year 1, we actually talked last year on a similar topic. You can look up Yanni and I talking why we bet our startup on Clojure. And yeah, this year it's just such a great topic. It really is worth talking more about. Just to recap briefly what we said last year. Yeah, so Clojure, it's a little bit of a niche language. It's far from the most adopted language. It's out there. There's definitely a little ecosystem of companies like us that use it. But you would definitely not call it mainstream. But in spite of that, it's a great language. And it turns out it's actually a great language to choose to make the bedrock for your company. All of our backend systems are built using Clojure. And yeah, originally we had Python. We did a migration kind of early on and have never really looked back. And when you're talking about a choice of a language for a company, you're not just talking about kind of an abstract choice of what would be the coolest language to use, I don't know, in a college course or in a side project or whatever. Because software is written by people, and we've got a lot of scaling challenges. You need a sizable team to be able to write the systems that we need just to drive the value here. And so you've got to be able to hire for it. And obviously you want to hire good engineers, and it's a very competitive landscape. So you've got to be able to attract top talent. You've got to be able to hire people who maybe haven't used it before or who are earlier in their career. And you've got to be able to train them in the language, and you've got to retain them. Just as we have to keep our software systems running 24/7, 12 months a year, we've got to keep all of our people, in the best position to succeed with their jobs. And we talked about how that in part means giving them a really good tool for that. So yeah, we talked about that. And I'm kind of just going to talk about how that's been going for us and go into a little more detail on why it is that this is such a great language. And yeah, why it works so well for us. So yeah, in the last year, I talked to you can see last year, the story of how we had hired for our team for the first couple of rounds. And again, last year we've expanded sizably, and this year, again, we're continuing to try and hire more people. And yeah, if you've kept tabs on the hiring market in tech lately, it's just gone crazy as we've gone to a remote world. Suddenly, pay scales are off the chart. You've got people switching jobs left and right. And it's just very hard, again, to just drop an anchor that is stable, that can attract the best talent. So yeah, our CTO, Buck, did this blog post about a year and a half ago on why we use Clojure at Crossbeam, and it's a lot of the same kind of content that you'll see anything talking about, like why to use Clojure. And yeah, we really got our money for this blog post because the two most senior engineers that we hired in the last year, including a staff engineer, which is the highest level of engineer band that we have here. Basically, we just heard from these folks like, hey, you guys use Clojure. Let's talk. So yes, this staff engineer joined our team, had been working for a publicly traded company, doing very well, but just had this pet interest in this language Clojure. And Google actually served him this blog post as an ad. And he just couldn't put that idea away, and ended up writing us a letter, and we got into talks, and well, he started last month. And yes, another senior engineer on our team also was looking for a new gig, knew he liked Clojure, and put out a feeler, found this blog post, and it's really been the single most effective recruiting that we've done. Recruiting, you've got to make a lot of plays that in themselves are low probability and just hope for some of them to work out. And this one has really worked out really well for us. But we haven't only hired at the top end of our bands, but we've also hired mid-level devs, a couple on my team in the last year. And I would say both of them have really thrived. Neither of them had ever used Clojure ahead of time. And so, it's given us a chance to sharpen and improve kind of our Clojure onboarding experience, the little curriculum that people go through. And I have to say, as the manager on the team, I, day to day, am not always seeing the work that every single contributor is doing. And so I've just had a couple of wow moments as I've seen how not only are these two engineers on my team just really doing a great job, knowing how to write an algorithm in Clojure, but yeah, Donna and Bailey both have really leveraged what makes Clojure unique, and they're doing things in really the Clojure way and having just this incredible power available to them. So okay, that's all very abstract and a little bit kind of unproven. So I wanted to go into some of what is special about that. First one moment I did actually ask the team as a lead up to this, I just said, hey, why do you all love Clojure? And yeah, I got a bunch of responses and just thought I would highlight a couple of them here. Make this a little bigger. Yeah, so Simon right away says, hey, I've got this note that I just keep handy on why I love Clojure. And you can see through, his like 8 different languages here. And it's just, this word love keeps coming up as we're talking about it. Granted, I framed the question that way, but people just voiced it of their own accord. Hans, senior engineer on my team, really said that Clojure just made coding fun again. It's kind of like a rebirth, going back to basics, remembering what it is about programming that attracted many of us to get into it to begin with. Noah, another engineer, joined our team, maintainer of a Clojure open source project, leads right off with like 8 different reasons. And then Pavani has been with us for a few years now, and one thing that she always mentions is it's not just the language, it's also the community. She's, in her experience, the Clojure community, people come from varied backgrounds, and it's just a really fun place to hang out. And we'll get a little more into Yanni's question a little later. So yeah, I'll just say one thing is having a technology that people use every day that they really enjoy makes a big difference for job satisfaction. Lots of languages are perfectly fine tools, but if I think of what I've done with JavaScript, I might say something like, well, it was okay, it's not bad, you can do some cool stuff nowadays, but kind of like pays the bill. Whereas with Clojure, again, it's this continual feeling of like, wow, it's so cool that we're able to do this, especially in our day jobs. So okay, right, so what is so special about all of that, and specifically, what is this Clojure way of doing things that I referenced that was really impressed that the engineers on my team had already gotten the hang of. And yeah, a lot of it is REPL-driven interactive development. And it's really kind of the difference between a forensic investigation of something that already happened or being an eyewitness of something as it is still happening. So your program is not this kind of just static thing that runs off somewhere else, but it has this interface right to your editor. You have code, and you can change the code of the program as it's running, and you can use that to kind of explore and look around. And yeah, one thing that's worth pointing out is that this wasn't at all invented by Clojure. Clojure is a member of the Lisp family of programming languages, and Lisp goes all the way back to, I think, 1956, and actually predates the C programming language, which many of us think of as kind of like the first programming language. And this idea of the program as this kind of living, breathing thing that you continue to interact with goes back, all the way to that dawn of Lisp. So Clojure is kind of the standard bearer for the Lisp way. It runs on the Java ecosystem, and so therefore it's really easy to just use it in production as we do here. Okay, I wanted to give a little demo of what this actually means. So let me go over here to my editing setup, and I'll start a server here for this little sample project. And the app that we're trying out here is simulating, you make a reservation at a restaurant and they text you to ask if you're really coming. So the kind of basic idea, you're going to Bucky Buck's Steakhouse, love you, Buck, is our CTO. They just ask you to text with 1 to confirm your reservation. So this is just a little toy example to imagine just that kind of app. So I go over here on my Emacs, and again, the idea is that this isn't just an editor that I run and then something else is taking my instructions and building a program over here, but that this editor will connect directly to the running program. So again, over here I've got running program has got a server running on port 3000, and then it's got an NREPL server running on 1234. So NREPL is this technology that we use to connect live to our program. And here we are. Okay, so, things always happen in production. So I've got a little shell script here, which just replies to the text. They asked to confirm 1, send a 1 to confirm your reservation. So I'm going to simulate that here. I send a 1. And it says, oh, thanks for confirming. We'll see you then. Looking forward to it. So that is our happy path. But, our program, as you can see, if it gets a 1, it says, great, thanks for confirming. If anything else happens, it throws an error. So I've just got this little, prod bug that I'm simulating here. So just imagine that we've got, somebody reporting that they're replying with a 1. They're texting 1, and they're just getting this error. And it's reported, the customer success team files a strike ticket, and you're the engineer on strike, and you're tasked with trying to figure out, well, what's going on. So that's kind of what we're simulating here. I'm actually going to just use watch here, and I'm just going to keep running this on a loop. So every 2 seconds, we're trying to create our prod bug here. And I guess if we manage to fix it, then maybe that text will change to our success message. Okay, so again, here we've got our program, we're running production. The first thing I want to mention, right, so developers are used to having a local setup that they connect to and provide some measure of interactivity. One of the awesome things about NREPL is that you can have NREPL running in any environment. So our engineers routinely, when they're investigating issues like this, they connect to a REPL that's in production. And so normally, of course, right, you would try to reproduce an error locally. Maybe you would add some log messages, and then you'd have to redeploy your code. to see the output of the log message. And then if that didn't give you everything yet, you have to kind of repeat that loop. There'd just be a really long interaction loop between trying to fix things. I'll make this a little bigger. And, trying something and investigating, trying something and investigating. Really the essence of rapid software development is being able to iterate rapidly, having a tight loop between making a change and seeing that change. So being able to do that in development is, one whole issue. And then having that power in any environment, including production, is really, I think, one of the main difference makers for what makes Clojure so great. So yeah, here I've got my handler body, and I'm just gonna okay. I've got an HTTP request that's coming in. There are some parameters. There's a text that's supposed to come out of that. What if I want to actually look at that? Again, like you could make a log statement and just see the result, but you have to already know kind of what you're looking for, and I don't necessarily know what I'm looking for when something is wrong. So I'm just going to capture this. I'm going to change my code, and now I'm going to send that code to the REPL. And the same thing that we started over here that was running, we just changed our program as it was running. And remember, we're calling this every 2 seconds. So I'm expecting that foo is going to have something now because we did it. Yep, you can see. And okay, look, there's a lot of stuff in this request. It could be a little noisy to try and get to the bottom or tail of it. So one of my favorite things about Clojure, specifically in Emacs here, is this inspector, which not only pulls up a dedicated window for it, but you can browse. You can turn on to it. Like, oh, okay, so these are the headers. Yes, it looks like they wanted a JSON response. All right, that's something. Okay, content length is 16. Okay, so it's not like an empty body here. But yeah, I'm not really sure what the issue is exactly. So let me just look into the params. And I think we may have our culprit here. I think there was some confusion because our message told the user to reply with quote one quote. And it looks like they're actually replying with quote one quote, whereas our program is only looking for the number 1. So yeah, of course, there are a lot of different things we could do here. We could go back, we could say, oh, it's actually user error. We could go to design and we could say, oh yeah, those quotes, they're actually a little bit confusing. I think if we took them out, people would know what to do. Or we could just make our program, handle it. So let's try editing it live. Again, I'm going to capture the text that's coming in here, and just every 2 seconds, I expect that to be populated. Yep, sure enough, I've got this text. It's just a string. All right, well, what if I just want to help out the poor people who may be confused in this way? So, okay, yeah, let's have a whole family of acceptable values that they could send. So I'm going to start a set. Love the Clojure syntax for this. It could be the number 1. It could be this string of 1. Let's even say like somebody's really feeling cheeky. Let's say if it's any of those things, then we will thank them for confirming. I'm going to reevaluate here, and yeah, let's see. All right, not found. We can see that the not found is the handler that something is falling through to here. And I'm not really sure what the issue may be. That's kind of the fun. So again, now somehow the very same request that we did before is, it is falling through. This function is not catching it at all. And I think the issue is, I have a set and then the message I was trying to send. I need to actually say that the text is one of those. So this is Clojure syntax for asking, is this thing in there or not? It doesn't like my cog because it needs an even number. I need to say that this is the last step of the branch. And yeah, we can test this. I've got my set here. And our bar, right, was that. And this is not nil, and that's how I know that this is going to evaluate to true in Clojure. Clear out my variables here, and I'm expecting, yep, we fixed the bug. Thanks for confirming. We'll see you then. So yeah, you can imagine that gives you kind of a live view of what it's like. Some languages have a compiler that tries to tell you right away when you made a mistake, and that is usually a very good way to do things. But there are weaknesses. Can your type system really express all of the errors that are important, the errors that you're really going to be hitting? This interactive, just sort of talking with the REPL as you're going approach is Clojure's answer to that. And yeah, personally, I've previously been an enthusiast of other languages like that, and I'm very open to this Clojure story that, yeah, maybe those classes of errors aren't the errors that you can find, and trying to express that in your type system, you're going to need to end up having an advanced degree in mathematics, and you don't really want other engineers to have to do that. Clojure gets you, that upside and more without a lot of the downside there. So yeah, I'll just come back to the note that Yanni had mentioned. Yeah, so he had mentioned the REPL and how it was really helpful in debugging a production issue. And this is just not a toy version. This is a very real version of exactly what I just demonstrated. So yes, we pushed data back to Salesforce, and we were pushing all this data, but then we were just deleting everything we had just pushed. So we're basically digging a hole and then filling it in again. And we couldn't reproduce it locally, so connected to production. And yeah, there are some different environment aspects in production. So he's able to kind of live sprinkle some inspection code, doesn't need to go through any review and release cycle, can just kind of poke and prod with it as we're going. And yeah, it turns out that we were doing this prefix in staging and production. We missed one spot where we needed to do that. So yeah, Yanni just was able to find that out with the power of REPL-driven development. So yeah, and we're not the only ones who have experienced this. You can look at, there's this great talk by Stuart Sierra, The Joys and Perils of Interactive Development. And he retells a story from NASA with their Deep Space One satellite, which had Common Lisp running on board. And this satellite was tasked with autonomously going to a place and taking pictures of things. And they turned it on and everything sounded good, but within a day and a half it had gone dark and completely unresponsive, and it looked like the whole thing might be lost, but it was a Lisp. It had a REPL running. Even though they're about 10 light minutes away, they were able to connect to the REPL, and they found, get this, they found a bug in the code, not the code that they had written, but the code that was on the satellite. It was a race condition, which is always a really tricky kind of thing to discover, had evaded all of their exhaustive testing at NASA and even a formal correctness proof. But still, the bug made it to production. In this case, production was this satellite millions of miles away. And they were able to connect with the REPL, find the bug, fix it, and save the mission. So yeah, I don't think it gets more extreme than that. Look into that story more. It's just really fascinating. I think that just gets at, again, a lot of the power that we're talking about here. So that's all one thing. I just wanted to kind of close with one other little tidbit, which is really its own note, but because I've focused specifically on not just the language in the software, but on the teams running the software, I thought this was really relevant. And you'll hear a lot of talk about microservices. I think there's another session at this DevConf. 10 years of microservices, kind of was it worth it, is the question. And yeah, so what microservices are trying to come at, I believe, is in part Conway's law, which basically says that the architecture of your human organization is going to end up reproducing the architecture of your software systems. And so if you want to have your humans only needing to have just a manageable amount of context that they need to learn and remember, then you need to architect your systems such that they divide up and that a given team can only be in charge of a subset of it and not need to learn everything and not get buried in complexity. So I know there are other reasons as well. I think that's a lot of what microservices are coming at. And yeah, in Clojure, we have something that gets us a lot of the best of microservices without the pain. So yes, our Crossbeam backend service is a single repository in GitLab, and it's a single deploy, of course, it's just one service. And yet, through components, which again is its own rich topic, we have each team basically owning their own subcomponents of that system. So my team is in charge of data sharing, and we recently published a data sharing component. So anybody else in the code who wants to, find data subject to data sharing in Crossbeam, they just call our service, and it's a lot like if you were to query a microservice that we had released and published and made available with a certain API, just without any of that work, basically. So it's just an interface in the code that we published that is very agile. You can kind of do phased rollouts. Again, it's a whole topic. Won't really go into it. But yeah, we really believe that by use of components, we're able to get kind of the best side of Conway's law, scale our systems in conjunction with scaling our teams, and it's great. It's Clojure, yeah. So yeah, that is us. Just want to, in closing, say, are you fed up with mutability? You feeling disconnected from your production server? You wondering where the joy has gone in programming, or maybe you're not an engineer and you're just having trouble recruiting, hiring, retaining a great engineering team. Of course, this little tongue in cheek here, there are a lot of ways to go about this, and Clojure is not exactly magic, but we have really found it to be a silver bullet for us here that we've kind of bet the whole thing on, and so far it has played out for us. So that's me. I'm Nick. We're Crossbeam, and thank you.
Thank you so much, Nick. And thank you to everyone who joined us today. We hope to see you in person May 10th at Per Pay for the IRL portion of this event. Have a wonderful day.